All right, everyone, welcome back to another lecture for COM 426, Modern Web Programming. This is lecture 4. So we're going to let everyone settle down for a moment, and then we'll get started with some announcements. All right. Some announcements. First, happy Thursday. Hope you all are having a great second week back into the semester. So I just wanted to recap some of the upcoming due dates. So we have A01, which is the personal portfolio assignment. You're actually getting started with using HTML and CSS to make a website. That will be due on Sunday. And then also there's a reading number 3, higher order functions, due on Tuesday. And I also said on Thursday that the higher order functions reading will kind of be, I know we've had a lot of readings in the first 2 weeks, but that should begin to reduce as we kind of get more into the semester. And then another note is that Monday is Labor Day, so there is no class. And so TAs will also not be hosting office hours. TAs follow the same calendar. So in the future, if we have wellness days as well, they'll not be working during wellness days. Are there any questions on the announcements? Great. Okay, so we're going to get started today. We're going to start off with a bit of a recap from where we were on Thursday and how we started this week. Good? Okay, so we started off by talking about HTML. So HTML was the language that essentially described the content and the structure of the web pages that we load on the internet. So we had HTML, and then we also simultaneously introduced CSS, which is going to be used for describing our styling. So how do we actually style our web pages? And then the last kind of key point that we got out of the second lecture was that together, HTML and CSS both end up providing the layout for our websites. Right? So for example, with HTML, you have nesting of elements, which helps us to create a hierarchy and also allows for flexboxes to work. And flexboxes, as you are maybe beginning to see as you're working through A01, allows you to have more control over the layout. So that instead of having all of your items stacked vertically, you can have items aligned horizontally as well. And then on Tuesday, we began talking about TypeScript. And so TypeScript was that final piece, right? We have the content, we have the style of our web pages, but the final thing was actual functionality, making the website do something. And so we spent a lot of time last lecture setting up kind of our intuition for TypeScript, why TypeScript is preferred as the language you're using over something like JavaScript. And also we talked about the setup. So we talked about Node and we talked about Vite and all the different things that are needed in order to set us up with working with TypeScript. Right? So we spent a lot of time working on the setup, but today we're actually going to begin to see how TypeScript can be used to make our web pages actually interactive and functional. Right? So the key kind of idea here that we're going to be exploring throughout about the lecture today is that in order to add functionality to web pages, what we're essentially doing is we are responding to events that occur on the website. And these events are essentially just describing user interactions with the website. So anytime the user is actually trying to interact with our website, we may want to run some functionality when some user interaction occurs. And so what I would like you to do, and this is kind of our first warm-up discussion here, in pairs around three minutes or so, brainstorm what are different ways that a user actually interacts with the web page. You can even just try to go on a web page yourself and see how do you actually interact with it as you scroll around. And we're going to spend 3 minutes on this, and then we'll come back and talk about it together. All right, everyone. We can begin to come back together here. So there's some great discussions. Does anyone have any thoughts on different ways or different user interactions that exist when a user uses web page? Yeah, we can start here. Exactly, yes, hovering. That's definitely a very common one. There are many cases where you hover over something on the website and then some action might happen. Maybe something will pop up or a color changes. Something might happen when you do that. So perfect. Any other thoughts here? Yeah. Exactly, clicking. So clicking on links, click on subpages, clicking on things like buttons, etc. So clicking definitely is a one of the most common ones that we end up with. Any other? Yeah.
2048 game where
Yes.
buttons probably should have spawned.
Exactly, yes. So what you're saying in the front was in a game like 2048, right? You have to use keyboard input as well, like arrow keys. There are many cases where sometimes you'd be using also your QWERTY keyboard or like and typing in things. So exactly, perfect. That is a great user interaction. Any other thoughts here? Yeah. Mm-hmm. Yeah, exactly. So yep, hovering. Perfect. So I think that is a pretty good summary here. There are a lot of different ones, but the ones that you all picked up on were kind of the main ones that you come across. So things like clicking on something, clicking on an element on our page, pressing a key on the keyboard, things like dragging, like drag and drop, for example. A lot of cases you have to use that. When a mouse like enters a region, so that's the same as hovering, when you're hovering over something. Also, when a user fills out a form, so like when you're submitting, maybe writing an email or something like that. So perfect. All right. And there's another link here, and this is a great resource. So if you have the slides open, you also will be able to access this. And this resource actually talks about a lot of different types of interactions that are built in. And we're going to be talking about this in a little bit and responding to each of these. The most common ones, again, things like click, things like hover are in here. There's also maybe some other ones like double click. Something like copy paste is one that is quite often used. We've talked about dragging, key presses, again, with the keyboard, etc. So these are all different types of user interactions, right? So very, very good. So the key idea here is that if we want to add some functionality to our web page, we often want to run some code whenever these user interactions happen. Right, so for example, maybe I want something to happen when I click on a button, or maybe I want something to happen when I hover over something, or when I press a key on the keyboard, etc. And so what we want to do then is we want to run some TypeScript code that we define when one of these user interactions, what we call events, one of these events occur, right? And so if you kind of think back to what we've had HTML, right? HTML defines the elements on our page, things like buttons or text or anything like that. And so elements are defined in HTML. So the question is that if we want to run some TypeScript code when an element in the HTML, it's defined in HTML, when that is interacted with, how do we connect the two? Right? Because right now we have standalone TypeScript files. How does our TypeScript code be able to interact with the HTML that we've defined, or the elements that we've defined? Right? And so here we go. How can we run TypeScript code when a user interacts with an element? And so in order for us to be able to do this effectively, we need to have a way from within our TypeScript code to be able to refer to elements that we have defined in our HTML. And so that is the first piece that we're going to build up. Are there any questions so far? Amazing. All right. So the main tool that you're going to be using to accomplish this is what is known as the DOM. This is short for Document Object Model. All it is it is just a representation, a data structure, if you will, that represents all of the elements on a web page. Right? So it shows the state of the content and the structure of the web page. And we define this, the DOM will take the shape of a tree. So I'm going to show an example, and you'll begin to see how that comes together. But ultimately, if we have this data representation of the elements in our HTML from our TypeScript code, then we're able to actually interact and to connect some functionality from a TypeScript code to elements in our HTML. Any questions so far? All right. So here is an example of a sample HTML page. You can see here that I just have HTML, and then inside of there, I have an element body. I have two divs, one with a paragraph that says hi, and then the other, if you remember from the reading that you had, the HTML CSS reading, A tags are links, right? So we have a link there that says just link, and it would go to some URL. So this is HTML, but how would this HTML be represented from within our TypeScript code. Right? So you'll end up with something that looks like this. So this is the DOM for this particular HTML file, or the document object model, right? This is our data representation of the HTML that we have on the left. As you can see, it does take the shape of a tree. We have different parts of it. So we start off at the top with all DOM trees start off with a document node. That's like our head, our root node here, that we use to kind of start off our DOM tree. And then we have a special type of element here called a root element. That is where our HTML element right here, which you can kind of see, this is the leftmost, right? This is kind of our everything else inside of our HTML document is inside of this HTML tag. And so HTML is our root element. And then for all of the elements that are nested inside, they will be children of the node of the node of the element that they're in. So for example here, we have our body element right over here. And I apologize, but my tablet was not working earlier. Let me see if it is now. Nope. So I will just kind of point at it here. But our body element right here is inside of our HTML element. And so therefore, our body element is going to be the child of the root element in our tree. Okay? And then inside of body, we have two divs, right? You can see there's a div there at the top, and then there is another div. And so these divs are nested within this body element. And so therefore, they are the child nodes of our body element there. And this continues down. So we have elements P and A, right? P is the child element of our div, and our link here is a child element of the other div. All right. Then finally, the leaf nodes, the nodes at the bottom, we have mainly text, and then we have attributes. So for example, inside of my paragraph, right, the paragraph at the top there, it says hi, exclamation point. And so we represent that text as a leaf node here in our DOM tree, and this says text. So we have a text and then hi. Okay? We also have some text inside of our link. So you can see here in the A tag, we have link there. That's the text. And so we'll add that as a child here in our tree. And then also, lastly, we have one attribute or one property in our tag, which is href. So you can see we have href equals URL. And so we need to represent that in the DOM tree as well. And so we will do that by adding a child node to our element A with an attribute href and a value of URL. And I think I jumped slightly ahead here, so I'll kind of bring in our other pop-ups here. So again, all child elements of an element are placed as children in the tree. Text has its own node, and attributes have its own node. Are there any questions with this representation? All right. So again, when you load an HTML file, and we'll actually be talking about this later, probably maybe in a week or two, but when you load an HTML file, your browser is going to create this DOM tree based off of the elements that are listed in your HTML, right? Any questions here? Oh, yeah. Sorry. Oh, for like in the title. Great question. So if you have some metadata, then it would be another element off of our root element. So let me see if I can draw this here. For simplicity's sake, I removed it from these examples, but so I guess you'd have, yeah, so if you have like a head element, you'd have head here. And again, I apologize because my tablet's not working here, so I have to deal with, sorry, bad handwriting, but you'd have head here, and then you would have other things like title and whatnot as children. I will say, though, that typically in these DOM tree representations, especially for this class, we're really only going to be diagramming the body part. The head is metadata, and it is part of the DOM tree for that the browser sees, but the browser, that's metadata for the browser, and it's not really elements that we end up interacting with in our TypeScript. Great question. Any other questions here? All right. So this is a bit of a, sorry. the mic again. So this is a bit of an interesting way of thinking about how our website is ultimately configured and the content, right? So we've seen now, like you see a website that you look at in your browser. We've seen the HTML now, which is another representation. And finally, we're now seeing kind of the data structure representation of it, which is a one-to-one to our HTML, like so. And the entire point, again, the reason why we have this representation is so that we can access this representation from our TypeScript code so that we can ultimately respond to different user interactions. And we'll see that in a moment. Any questions? All right. So you're going to have the chance to practice drawing one of these out now on your own. So what I've done is on the left-hand side, I have an HTML file, which you can draw the tree for. And then I also provide here the 5 different types of actual like nodes in our tree that we don't have to worry about necessarily memorizing those. And so we have paper here, and the TAs are going to help me hand this out. Feel free to work with 2 or 3 people. This will be our attendance check for today, so you can submit it on Gradescope. You can add multiple people. It should be on today. And we'll spend 5 minutes on this, and then we'll come back together and try it out. All right, everyone. So we're going to come back together. No worries if you're still working or almost done. Seeing great progress. So remember, this is going to be the attendance check for today, so you can submit an image of it. If you're working with multiple people, you can add them also to your submission, and that'll be totally fine, and everyone will get counted present for today. So we're going to work on this. We're going to work on this together now, and so you can see what this would end up looking like. And the Gradescope is still open, so even if you're still taking photo, do not worry. All right. All right, so this is what this is our HTML that we had. So can anyone tell me what we would start off our DOM tree with? Like, what is our root node of our tree? Yeah, document, correct, exactly. So the first element in our tree is always going to be document. So I'm going to add that here. So I'll just write document. And I apologize, I'm trying to there we go, document. Perfect. So that is our first element. That's our first node in our tree. And then what would be directly underneath our document node? Yes. HTML, exactly. What type of element, or sorry, what type of node is that? Perfect, exactly, root element. So right underneath our document, we're going to have a root element. So I'm going to draw that here. So we have root element. I'm going to abbreviate element with EL for the sake of time, and we'll write here HTML. Exactly, so we have a root element right here. Perfect. So we have root element. And then what is the child or children of this root element going to be? Does anyone have any thoughts on this? Yeah. Element that's body, exactly, right? So if we look at our HTML here, you see we have element, whoops, right here. What is our one child in here? That's going to be our body element. So we'll add that. So we have L, body, right underneath. Perfect. And then I'm going to now work through this. So inside of our body, and the way that you can kind of construct this is you can go outside in, right? So now we're working inside of our body. So what are the children of this body element? Well, we have H1, P, and div, right? Those are our 3 elements that are nested inside. So I can draw those out as nodes that are children of our body element. So I can have element here, which is H1, which is its own box. And then we can have an element here, which is our paragraph, which is its own box. Whoops. And then we have another element, which is our div. All right, perfect. Can anyone tell me what the child of our H1 element is here, or our node. Yeah. Exactly, right? So even though we don't have any elements inside of H1, text is still a node in our tree. So we're going to add a text node right here, which is, I'm just going to write here txt and welcome to comp 426. Perfect. And so this is a child of this H1, and I'll also draw in my other lines real quick. So here, here, and here. All right. And then for our paragraph, how many children should be underneath our paragraph node? 2, exactly. Which we asked which 2? Yeah. Yes. Perfect. Yep. So that is our first one. So we're going to have here, whoops. We have an attribute. So I'll just abbreviate again for the sake of this. So our attribute is ID, and then our value here is going to be text, right? So this is our attribute that we're trying to map. ID equals text. So value is equal to text. Perfect. And then it said there were 2. So what's the other one? Perfect, exactly. So we'll draw that out here. So text, hello world. Again, I apologize for the handwriting here. And then inside of our div, I'm going to kind of also, there's not that much space here, but I'm going to show what this is, because there was actually a lot of good questions here about this, because our div has both an attribute, but it also has 2 elements. And so the way this is that our attribute, just like how we had with our paragraph above where it said hello world, we had an attribute that was directly attached to that element. So whenever you have an attribute, that is going to be a direct child of that node. So our first child of div here is going to be, and our first child here is going to be the attribute. So this is an attribute of class and a value of row. And then at the same level is going to be our other elements. All right. So I'm going to real quick just I have a screenshot of this that I've saved, but I want to clear this and just expand it one last time so it's easier to see. And I'll do this all in one color. So we have our element, which is our div. And then underneath it, you have your attribute, which is your class. Your value is row, right? This is this right here in our div. And then underneath that, you have a element, which is a paragraph. Underneath this, you'd have text, A01. And then here, element, paragraph, text, A02. All right. So does that make sense? At least this example here. All right. So once you kind of know the intricacies, particularly regarding things like this, where you have attributes and you have values, these trees and building them becomes a lot more mechanical, and you'll be able to follow kind of a standard process for that. In addition, I believe later at some point, maybe next week, there'll also be a full practice with around 5 or 10 of these you can do with answers as well. The main purpose of this is just to have kind of a better sense of what is actually happening when we ultimately are going to be interacting with elements from our TypeScript, which is coming next. All right. Any questions here with our DOM tree representation? All right. So now we kind of are connecting back to reality, right? We had these diagrams that we talked about, but where is this actually in our TypeScript programs? Right? So this DOM representation is actually stored in an object inside of your TypeScript file. So any TypeScript file that you have that's part of your web environment, when you're loading in on your browser, you are going to be supplied with this document object. And this document object is going to store your DOM representation. And so then it's really easy to be able to create variable references of HTML elements by using these document APIs. So you can see here, one of the common ones, which I'm going to show an example of, is document.getElementById. So that's going to search the DOM tree. It's going to find an element with a ID that I supply, and it's going to save that element, the reference to that element, in a variable. All right, so I want to show this here. Feel free to open this up as well. This is on go.unc.edu/426-L04. And so what you'll see here will be something very similar to what we ended up having last time. So we'll get that open. And I am also going to open something here real quick, if I can get there. All right, so what you'll see here, and what you should see on the screen now, is a very basic website here. And this is not L5. I think it's L4. So that is a typo on my part. I apologize. It says L4 at the top, but I'll change that. So what we have a website. We have two buttons. We have a add element and we have an increment counter. And then we also have this text that says current count 0. Right now, this doesn't do anything. So if I press on any of these buttons, right, nothing happens. Our page has no functionality at all. And what we're going to be building, we're going to be adding functionality to this page. And we're going to do that using our DOM representation. Right? So the first thing that I want to do is essentially what we're going to have is by the time we're done with this example, you can press this increment counter button, and the counter that you see on the screen should increase. Right? So right now it's at 0, but we want this to increase to 1, 2, 3, etc. as we press this button. So what you'll notice here in my file explorer is you'll see an app.ts file, and there's nothing in it right now, right? So if I pull up my HTML here, and I wonder if there's a way for me to dual screen this. Okay, there we go. App.ts, nice. Okay, so this should hopefully make it a little bit easier for us, make this smaller, right? So you can see that based on our script tag that we talked about last time, we are linking ultimately to this TypeScript file. There's a lot of stuff behind the scenes that's happening that V does, right? It does that conversion from TypeScript to JavaScript, etc. But what I want to do now is if we want to adjust what this counter is showing, we first need to have access to that element in our TypeScript code, right? Otherwise, there's no way for our code to be able to interact with that element. And so as you'll see here, we can begin typing in TypeScript, and you'll see that document is something that shows up and is available for autocomplete. This is our reference to the document object model that we've been diagramming. That essentially is the data structure that has the HTML representation loaded in. So I can write here like document, and there are many different APIs that you'll see. One of the most common ones that you'll use is this getElementById. It performs a search, and it finds the element on our page that matches that ID. Remember, we said back in the HTML lecture that IDs should ideally be unique. Right? So I can click on getElementById, and what is the element that I want to grab from my HTML? Well, we want that 0, right? It says current count 0. That's what we ultimately want to change to 1, 2, 3, etc. And if you notice in our HTML, we have an element there called span that has ID equals count. And inside of that, as the content, is that 0. So I can type in count here. And what this will do is this will return back to me that element as an object in my code. So I can save this to a variable like const, like counter or count label equals document.getElementById. And now that I have this, I can do something with it. What I'm going to do real quick is I'm just going to log it, console.log, to show you what this would look like. And so I can say console.log count label. And console.log, there's actually a nice property here, which should appear, called inner HTML. And let's see here. OK, this is another thing with TypeScript. So you may have seen this in the reading, you may have not. whenever we are grabbing our document, right? Or sorry, when we're grabbing this element from our DOM tree, there's no guarantee that it actually exists or not, right? We're saying document.getElementById, except we do not know whether or not we're actually going to be able to find it. I can write that same code and not have that element in my HTML, and so we need to be able to handle both cases. And so why we have an error here is because if you highlight over, it says count label is possibly null, right? So it can either be an HTML element, we find it, great, or we don't find it and we just return null as no value. And so we want to handle each of these cases. Now, if we want to basically tell our program that I for sure know that this element exists and you can treat it as though, like, if we get null, we'll just throw an error instead, you can add an exclamation point to the end of our line, like so, and your error will go away. So adding this exclamation point basically tells TypeScript that either you find a value and we continue on, or we're just going to error out and say that we cannot continue. Ideally, in a real application, you would not want to do something like this because you want to try and handle all your different error cases. Something like in Java, you usually had like a bunch of, in Comp 301, a lot of different errors were thrown and you caught them and handled them. Here, I'm just going to tell TypeScript that I'm forcing the program to say that this object either exists or we're just going to error out. And that's why you can see now that the type of count label when I highlight over is just HTML element. It's saying that that variable that we've created is going to be of type HTML element. If I removed this, it says now that our type could either be HTML element or it could be null, right? So just by adding that exclamation point, we are removing the possibility of a null value being stored here. All right, so now I'm going to show you what this looks like by jumping over into, looks like it's cut off here. In order for me to open this in the new tab. There we go. So that I can show you the console when I print this out. Console. And you'll see two things end up printing. The first thing that prints is our HTML, right? So we said that we're printing count label. That's the first thing that prints out. And then the second thing that prints out is the content inside of it. So when you write inner HTML, that is just grabbing the text that is within our closing and ending tag. Okay. Any questions so far? All right. So now we have this count label object in our code. I can even go as far as to try to change it dynamically and to change our inner HTML to something else. So what I'll do here is I'm going to write, and I want my preview to come back, count label.innerHTML. Let's just set this equal to 8. So we'll set this equal to a string 8. And you'll notice that now in my website, because remember, when I load my JavaScript or when I load my TypeScript code, it runs from top to bottom when we load our web page. It ran this code top to bottom, and it changed our website from displaying a 0, which is what our HTML said, to an 8. Right, so this is our first using kind of our document model, this document object, to modify the DOM and ultimately modify what we're displaying on our screen dynamically. Right? So the DOM, this object, is the single source of truth for how your website is actually going to appear to the user. HTML sets the initial DOM tree, but then we can modify the DOM using these type of commands and these type of things here to actually modify in the end what the user sees. Are there any questions so far? All right. All right, so this is our first real example of actual TypeScript code affecting the website that we see. All right. So that's as far as we've gotten so far in terms of the ability to actually grab elements. But now, how do we actually run code when we have these user interactions that we talked about, like clicking or hovering or anything like that? So let's go back here. Right. So again, the key idea that we started with is that we want to run some TypeScript code when one of these events happen on our website, right? Event is analogous here with user interaction, things like clicking, hovering, etc. And so I have here, recall, right, elements are defined by HTML. So how can we run TypeScript code when a user interacts with an element? And now that we have the DOM, we have the ability to access our elements from our TypeScript. And so now there's a lot of different things we can do with that. Particularly is this. So using these DOM objects that we get back whenever we, for example, run document.getElement, it returns back, right, an HTML element object. And one of the methods of this object is addEventListener. So what addEventListener does is we will supply first a string. This string is going to describe the type of interaction that we're doing. In this case, click is one. And then the second thing we pass in is going to be a function that we want to run when that event actually happens. So there we go. We have, again, text representation of the event. And then what I really want to kind of highlight here, again, because you saw this in the TypeScript reading, and if you kind of started with the higher order functions reading, you have already seen the syntax before. But remember that we can define functions in TypeScript using our arrow function syntax, right? So I can say, for example, let's just say let foo equals, and then we can define a function in line like so, and run and say maybe like console.log bar, right? And so this defines a function. So this is the same type of way that when you were just write function foo parentheses, and you have a body that has console.log, this is equivalent, where we can have let foo equals, and then we use an arrow function instead. And what you'll learn as you go through the higher order function reading is that this right here, right, just like how whenever you define any other type of variable, let's say let x equals 2, right, let name, right, equals like my name here, we use the syntax where on the left we have the variable name, and then on the right we have a value that we're storing. Right? So functions, typically we think of them as processes that we ultimately run in our code. But with this idea of higher order functions and arrow functions, we end up storing functions as values as well. Right? So this right here is a standalone function. Any questions so far? All right, and where this is leading is then this right here. So we have an arrow function defined like this as the second parameter to our addEventListener method. Right, so we're passing a function in as the parameter of another function. So this is known as a higher order function, and you're going to see a lot of examples of this in the reading, which is why we have a reading on it, because coincidentally, web programming and TypeScript uses a lot of this as we go forward, right? So this is an example of a higher order function. Idea here, though, is all we're saying, I want this function right here to run whenever that event happens on my element. Any questions with that? All right. And again, I can go back to this reference here that I had before. There's many different types of events, and these events are usually lowercase, and they're written like this. And so we can, the name of the event is what you'd pass in as the string, the first parameter. So for example, click is the main one right here that we're using. So we're saying whenever an element is clicked on, we want a function to actually run. All right, so let's see an example of that now. So if I were to go back to my TypeScript code here, I've changed the inner HTML here, but let's now use this addEventListener function. So count label, right? That is the element that we have. That's one element, but that's not the element that we want our user interaction to be tied to, right? We want, whenever we press on this increment counter button right here, whenever we press on that, we want our counter to actually increase. And so first we need to have a way to then add this event listener to this button. And so again, just like before, where we used document.getElement by ID to get that object in our code, we're going to do the same thing with our button. We want to have a reference to our button in our TypeScript code in order for us to add an event to it. So this would be like const increment button. And this is going to be document.getElement by ID. And the element here, what is the ID of the element? Well, if you look at our HTML, you'll see button increment counter has ID equals increment. All right, so we can use that ID to find that and store a reference to that element. All right, like so. I'm also going to remove this line so that we start off at 0 again. Perfect. All right, now we have a reference to an element. Now we can add an event listener to this element. So I can write here like increment button. And then we have add event listener, right? This is our function that we showed. And what we're saying here is that we want our label to increment by 1 whenever we press on this button. So click is our event. And then what do we want to do when we press this button? Well, it's going to run some function that we need to define, right? So I'm going to do that here by writing an arrow function. All right, so again, this syntax does seem a little bit weird, especially if you're new to TypeScript and haven't seen this before. The idea that we're defining a function as a parameter here. You'll get a lot of practice with this, again, throughout the reading and throughout the class. So this might be the first time you're seeing it, but once you pair this with also the reading and also our next coding assignment, we're going to be doing a lot of this. It should become a lot more familiar. What I'm going to do real quick is I'm just going to do a bit of a test run and just pop an alert up to the user when our button's pressed that we know it's working. Right? So I'll just say, hello from the button. So now when I press on increment counter, you should see that this event has fired off. The function that we've defined has now run when we press our button. All right? Any questions here? All right, so now in order to really make this work, I also want to, since we're incrementing some counter, I'm going to create a counter variable. So I'll have like, we'll just say let counter equals 0. And this counter will be our first, we'll just say count label dot inner HTML equals counter, just to start off with. Nothing should really change here. Let's see, number, oh yeah. And so we also need to wrap this in a string. So the syntax for this, if you want to put a integer or put some number inside of a string, is instead of using double quotes for your string or your single quotes, you can use like the backtick. So the backtick on the top left of your keyboard, and then you would add it's $sign and then braces like this. So if you have $braces, then anything in here would just be taking your value and basically inserting it into our string. So if I save that now and I refresh, we should see something here. Stackputs sometimes gets buggy, so there we go. So you can see it's working on our separate tab. And lastly, what I want to happen whenever we press this button, I want to increase the counter by 1. So let's do that. So I'm going to have here counter equals or plus equals 1. All right. Will this work? Let's see. So if we go to our new tab here and we press our button, right, you'll notice nothing actually happens. The reason is because, and this is something that's very important to remember and to conceptualize, is that even though we have set inner HTML to be this counter first, remember that only happens one time. It isn't permanently tied to this variable. All right, so every time we change counter, we also need to update what our label actually shows. And so if I paste this in here, right, so now instead of just incrementing the counter, I'm also updating what my label shows. And we go back here. And now you'll see that as I press my button, my counter is increasing. All right, so I'm increasing that variable that I have, counter, and then I'm updating what that element actually is displaying to be the new value of my counter. Are there any questions so far? All right. So the last thing that I want to do real quick is, but before there's a few slides that I wanted to get to as review for a Tuesday as well. But I want to very briefly also mention the fact that you can also create brand new elements from TypeScript as well. So not just taking existing ones and working with them, but you can also create entirely new elements. And let me see if I have a, yeah. So I will show an example of this real quick. So we have our increment button, which was the one that we had for adding our counter, but we're also going to use now that other button on the left, which you cannot see because we don't have dual screen. This one right here, add element. And so whenever I press this button, I want a new piece of text to show up on my screen. And unfortunately, this will go slightly faster because I want to write the code here. So if you want to watch instead of following along, totally fine. So I'm just going to first create a reference to my button in the same way that we did. Remember, we need to have an object. We need to have an object for our button in our TypeScript. Otherwise, we wouldn't be able to add any interactions to it. So we'll write here document.getElementById. And then the ID here is add element. So add element. Oops, that did not copy at all. Add elements. Okay. And whenever this is pressed, we want to perform some action. So we're going to have the same type of setup where we have a event listener. I think I need my, there we go, add event listener. So whenever we click, we want to run this function. And so how we create new elements is using the document.createElement API. So let's say I want to create a new paragraph. I can say const p equals document, which is accessing our DOM object. Then we want to create a new element. So create element. And what we pass in here is going to be the tag of the type of element we're trying to create. So if I want to add a paragraph, what is the tag for a paragraph in HTML again? Anyone? P, exactly. Yep. So that is all you need to create a blank paragraph. And then using the same type of idea up here, I can fill in now my blank paragraph with some text by just modifying the inner HTML. So inner HTML equals hello. And now lastly, I need to tell, or using TypeScript, I need to essentially specify where in my website I want this element to actually go, right? So where in my HTML do I want to actually add this to? So I have this div here called container, which is empty. And what I want to do is every time I add or press this button, I want to add a paragraph to this empty div. So to do that, we need a reference to it again. So I have to write here const container. And remember, we can find this element by using getElementById. Element by ID. Container. And I can just write here container dot, I believe it's append. Wait, I need my, here we go. Append. And I can just append P, my paragraph, to the end of the container. So all it's going to do is if there were other elements inside of it, it's just going to add it right to the end, right underneath anything that's already in there. So now when I go back to my site and I press add element, you'll see that we're now adding dynamically new paragraphs to our page, right? So that's kind of completing this idea of the DOM where we can find current elements, we can modify current elements. We can also add elements to our tree. And there's also deletion. There's deletion APIs as well. Any questions here? All right. Perfect. So this is a very powerful idea because it gives us the ability now to, instead of just having web pages that show content, we can actually have some sort of actions run as we interact with our web page. And that kind of starts off our idea of making websites functional. And throughout the class, you'll see that we're going from this idea of just working with simple buttons, and then we slowly build it up until you have very large, complex functional applications. Now, I want to spend, we have about 10 minutes left here. So these slides can also be, I'll go through them very briefly. You all, if you took Comp 110, this is basically reiterating what you've seen in a class like Comp 110 or 210. Everyone's favorite part of Comp 110, I know for sure, right? The stack and the heap and your memory diagrams. I know this is a really exciting stuff, and I'm sure all of you are very excited to see this again in your comp classes, right? We're going to skip this discussion here. I'm just going to kind of give an overview. What I really want to make sure, though, is it's been a while probably since you've seen this, especially if 110 or 210 is the last time you've seen it. But the reason why we're bringing it back is because there are some, in order to help understand how functions and these higher order functions things work, we need to have an idea of how these things are represented in our memory model. So in core classes like 110, 210, maybe 211 and 301 as well, although that I might be slightly out of date on that, you learned about the stack and the heap. Right? These are two core components of a program's memory model. Particularly, right, we have the stack or the call stack. This is responsible for keeping essentially our scope, right? What function we're currently executing, what variables are defined within that function, etc. And then the heap is used to store things like objects or function references, function definitions, etc. Right? So you spend a lot of time in a class like Comp 110 or 210 drawing out these memory diagrams to better understand how data is actually being stored as you're running a program, and how running a program actually works under the hood. Right? So typically you saw something like this. Again, I'm going to go, this is a very small example of just creating a variable, creating a function, and running the function. But I want to show this again so that everyone can kind of, it can, deep within your mind where this is locked away behind lock and key, you can kind of begin to claw this back up into your memory, right? So the first thing we always start off with is this globals. And also, it's interesting because it looks like on here, I have if you load the slide, there's like a nicer gray box, for some reason not showing up on the screen there, but we have a box for globals. This is our stack frame. So we have a global stack frame when we start our program. Any global variables that we define will be put onto this frame. Right? So for example, let's say we start running our program on line 1, the first thing we do is we are storing a number into a constant called num. So how we typically go about this is we will add an entry. Also, again, I jumped a little bit ahead, we have two columns, right? We have stack and we have heap. Boxes in that column represents stack frames. I also have a little identifier here for determining which frame we're currently on, so it's easier to see. And boxes on the right side will represent the heap. All right, so again, if we were to define this variable num, you'll see here that in our stack frame, we'll add num, and then we'll add the value that is stored there. So in this case, 426, that is it's a value type, so we're just going to put it in here, like so. Now, if you remember back from 110, if you're working with functions, right, where do functions actually go? Right, so I am creating this very simple function that takes in a number, halves it, and returns the result. Does anyone remember what we would do if we got to this line? where would our function definition end up being put? Is it put in our stack or is it put in our heap? What would this look like? I know it's been a while since you've probably seen it, so, but does anyone remember? Sorry? Exactly, yes, perfect. So it is in the heap. So any objects that we define, any reference types, but also functions, those references are placed here in the heap. So what we would do is we would create an item in our heap which is going to reference this function, right? So how we do this is we assign an ID. So you can see here we assign an ID to a new heap item. And then we have P. Now, apparently, because I was talking with some 110 TAs before this, and some of you may have seen this part, others have not. All this is a what we call the parent frame, which is just referencing what stack frame was this function essentially created on. See here we were in our globals frame F0. We create our function, so our parent is F0. And all this is, all we write in here, we just say this is a function, this is Fn, and this function is defined from lines 4 through 6 in our program, which you can see on the left-hand side. Questions here? All right. Now that we have created this function in our heap, we now need to store it and give it the name that we've specified, right? So we said have, that is the name of our function. And so how we go about this is, yep, we have our ID. We'll add have as another item in our stack frame, except the ID, this time instead of putting in a value, we want to reference the function that's over on the heap. So we're going to add ID 0 here. And again, these two are the same. So we have the item on the heap at ID 0, and we're saying that this have function, this is referencing the function that we have defined over there on the heap. Questions with this? Again, I know it's like, you've seen this before, I promise. If you've taken 110, it's just, it's the idea of getting kind of back into it, which is, you know, maybe some of you are not looking forward to it, but don't worry. This is mainly the reason why we're doing this is because on Tuesday, it will help to explain how a certain feature of TypeScript works. That's the reason why we're bringing this back. Right? So now our final thing is how do we actually call a function? That's the last piece of the puzzle here. Well, remember when we call a function, we're going to add a new frame onto our stack. Right? So how this works is, and when we'll move our active frame now is have, because we're running this function. Right? So we create a new stack frame, and there are 3 parameters. So we specify RA, that's our return address. So that's what line in our program is that value going to be returned to. Then we have RV, which is blank right now. That's our final return value. That's the output of our function call. And then we have any parameters that we pass in. So since we passed in here, we called have num, we are passing in the value of 426 into our parameter. Right? We're running this function. This is the function that we're running. And so x has been filled in with num. And that's why we have x as 426 here. Right? So finally, what we end up with here, is, right, we are now on line 5. We will calculate, we're saying we want to return half of what x is. So our return value is going to be half of 426. It's going to be 213. And then finally, now we have done running our function, and we're saying that that result of our function call is going to be stored to this variable named result. And so in our globals frame, we're going to create a variable for result, and the return value here is going to be placed into that slot there. So ultimately, what we're ending up with when we're done with our program is that we have a variable named result, and it has this value 213 in there. Function's value is returned, and we then pop off that frame from the stack. All right. So this was that was an extremely condensed, more condensed than I would have liked because we spent more time working with the DOM, which is okay. So what I would recommend is try to click through the animations again. Maybe look at some of the, if you have any of the material from 110, you can look at, we're going to do this same example again on Tuesday. So the entire idea of this is just to get everything into your mind. And I hope you all have a great long weekend, and we'll see you on Tuesday. If you have any questions, feel free to email me, or you can come to office hours. We'd be happy to help.